Okay. Well, yes. Welcome to 10th Week Variety. This is our very last lecture together. Oh, yeah, that's right. Thank you. It's like a studio audience. Well, I hope you've enjoyed the course. I know the homeworks were hard. I know the midterm was tough, and you got this final looming over you now. But I hope you feel like you've learned things in the course. That was the point, and I hope to see you guys in the future. It's been a pleasure teaching. But before we get started on today's stuff, just wanted to ask if you guys had any questions or anything to say. I'll listen, and then I'll try to answer your questions. And yes, question.
I just always wondered this. Is there a reason that you always wear red?
Is there a reason why I always wear red? I just like the color red. I guess a few years back I wore a red polo shirt, and I said, I like this. And then there was a sale on the internet for some more red polo shirts. I said, I'm going to buy a couple. And so I had 3 red polos, and I said, oh, you know what? I think I'm going to wear these every day for the rest of my life. So from there, I bought more and more red polo shirts. Whenever there was a sale on red polo shirts, I'd buy more. I'm probably up to about 18 red polo shirts, which allows me to go 3 full weeks without doing laundry. And apparently I have a red track jacket on right now. And that's the story of my life. Okay. Okay. Anything else? Yes.
I know you have different brands. The shade of red is a great concept. Do you prefer cotton or polyester?
I would go with a polyester blend. They're generally wrinkle-free, which is very important, as I am too lazy to really iron my shirts. If I get a cotton one or a pike polo, then I'll have to put it on the garment steamer and spend an extra 2 minutes waiting for it to heat up and then steaming the shirt. But when you use up the other 13 and you got the 5 cotton ones left, then that's what you got to do. So anyway, okay. I was expecting questions along like, can you explain this thing about, I don't know, the randomization test or something? But sure, you want to talk about my wardrobe, that's fine. I do have other shirts and clothes that I'll wear on the weekends. Wearing only the same thing every day makes getting dressed very easy. I just reach in the closet and pull something out and it works. It's much more work getting dressed on the weekend because my wife says, you're not allowed to wear red polo shirts on the weekend, so I have to pick between white and blue and whatever other. Okay, anyway. Yes? Yes, you are allowed to jump directly to 102C without taking 102B prior to that. The prereq for 102C and 102B is 100B, so you do need that. I would say, linear algebra is a prereq to getting into the stats major in of itself, and I would say your linear algebra is going to be very vital for 102B and also 102C, and so if you need to review your linear algebra notes, then do that as well. But yeah, the only prereq for 102B and 102C is 100B. I think 102A should be a prereq for 102B and 102C, but technically it's not, which all of you guys have taken 102A, so that's fine. But sometimes I get students in 102C who haven't taken 102A, and I'm always a little scared for them. But that's that. Okay. But yeah, you can take the series out of order. Yes?
Are we having office hours next week?
Am I having office hours next week? I was not planning on it, but I suppose I can come to campus one of the days. Maybe I'll decide and I'll let you guys know. Okay? After yes, Natalie. 102C does have a final, but it's on 10th week Friday. That's because I have many graduating seniors in that class, and I didn't want the final to conflict with graduation ceremonies, because sometimes like they'll schedule a final on graduation day and like on Friday of 10th week, right? Like that exists during spring quarter, Friday of 10th week. And for a class where a lot of your students are graduating seniors, that just doesn't fly. So so yes, you should definitely go to graduation if you're graduating. And so in 102C, the final is 10th week Friday. So we don't have this lecture, we have a test. Okay, any other questions? Yes.
I'm assuming then there's no like, there's a TA run review session next week or nothing of that order? No?
There's nothing. No TA discussion sections. Okay. Yeah. Yes. You. I'm sorry, I don't know your name.
How like advanced linear algebra should you know for like 102
I don't know. How advanced? That's like how hot does the sun get? It gets like. I would say if you got through 33A, is that the number for linear algebra? If you got through that, then you're good. Okay. So, matrix like you should know what. I don't know. Like finding the determinant. Know what an eigenvector is. Okay. There's a bunch of good videos on linear algebra. Look up 3 blue, 1 brown. I don't know, have you guys heard of this guy? 3 blue, 1 brown on YouTube. And he's got a playlist for linear algebra. It's like excellent. 5 stars, okay? Five star. Okay. Yes.
For next year, are you only teaching 102B in the winter and then 102C in the spring?
I don't know what my course schedule looks like next quarter. Okay. I think if I had to guess, it's 102C in the fall, 102A in the winter, and 102B in the spring. That's my guess. And I think also I'm guessing 131 in the winter and 131 in the spring. I'm guessing. We'll see. The 131 Python class could be a complete bust and then they cancel it forever. Okay. It's a guess. Right. Yes, more questions.
How much like prior Python knowledge do you think someone would need to take 131?
0. Okay. So 131 is taught. I'm teaching 131 as if you know R and know Python. So it's gonna, like if you take Pick 16, which is an excellent Python course, they start you off with just kind of Python. Here I'm kind of starting you off assuming you understand R. I think 102A is a prereq for 131. So I'm assuming you understand vectors and matrices in R, which will allow us to transition to the Python NumPy arrays and stuff, pandas, which work, okay? But I don't expect you to know any Python. And I'm also going to try to cover Git and SQL. Okay. Yes.
I have a stats question.
Great. Thank you. Yes.
It has to do with randomization tests.
Randomization tests. All right, let's talk randomization tests.
So for a randomization test, how does the number of I guess what kind of confused me is like on the homework we had a for loop and then we had a boot call inside the for loop. So,
Wait, a boot call inside the for loop? For randomization tests?
Not from the homework, but from the notes from one of the past lectures.
Okay, let me think about this. But go on.
So it was like a for loop that iterated like 1,000 times or 600 times or something, and then inside boot call we iterated 1,000 times. So it's like 500,000 or 600,000.
This wasn't a meta study. This was a randomization test.
Oh, sorry, yeah, for the meta study.
Oh, okay.
Meta study.
That's something different. Okay.
Sorry.
Got me worried here. Okay. So we're talking about Bootstrap meta study. Okay.
Yeah.
Sure. All right. And you're saying you have the outer for loop, and inside the outer for loop, in 1 through something.
Yeah.
Inside here, we have a boot call
So I was curious for the
with some number here.
what are we like doing conceptually when we're iterating in the for loop versus when we have iterations in the
Okay, this is a good question. All right. So the important thing, okay, so within one loop, okay, so this is, we'll just talk one iteration. So in one iteration, you're going to do Bootstrap, okay? And Bootstrap is basically a way to do a hypothesis test, okay? Allows us to do a hypothesis test without using a normal or t-distribution. Okay? Because if you think back to Stats 10, whenever you did a hypothesis test or a t-test, a hypothesis test, whether that be a z-test or a t-test, at some point you get a test statistic that you look up in your normal table or t-table, right? Because the hypothesis test requires you to do that. Bootstrap says, I don't like tables because I don't trust them or something, right? That's effectively what we're saying. When we choose to do a Bootstrap thing, we're saying, I don't think the tables apply to my situation. I don't think this theoretic distribution applies to my situation. That's the primary reason why we would use Bootstrap in the first place, okay? So you call boot, and so what boot is doing is it is saying, I don't want to use the normal or t-distribution here. I want to be the generator of my own sampling distribution. I want to create the sampling distribution myself, okay? Because in Stats 10, we're basically saying the sampling distribution looks normal or like a t, okay? Boot says, I don't believe I want to use normal table, normal or t-table. I want to make my own sampling distribution. Okay. So basically, your R here, the replicates here, the R in boot is how many values are you using to create your sampling distribution? So if you only use 100 replicates, you have 100 values in your sampling distribution. And we want to see how many of those 100 values produced test statistics that were more extreme than your observed test statistic. Okay? So our empirical p-value is equal to the proportion of basically of values in the sampling distribution that are more extreme than your observed sampling distribution. I'm sorry, not observed sampling distribution, your observed test statistic. That's what we're doing when we do Bootstrap, okay? So probably you would want R to be something like 400 or 500, maybe 1,000, okay? All of these, the bigger you have R, the more work your computer has to do, because it has to redraw a random sample, calculate a test statistic, and store it. And we want to know how many of our values in our sampling distribution that we are creating ourselves end up more extreme than our observed test statistic. Okay. Yes?
So for the meta study, we draw a sample of the data and then we run Bootstrap on the sample.
Okay. Perhaps it was a mistake to teach you the meta study. So that's Bootstrap, okay? If that's what you walk away with and you learned Bootstrap for one thing, great, okay? That's all we have to worry about, right? And in fact, I'm not even testing you on the meta study. I know it was in your homework in task 4, and I know like many of you suffered. But that's okay. I'm hoping you'll understand. You started wondering, yeah, we're asking the right questions here. Okay, so that's one iteration of Bootstrap. The question in the meta study, okay, so, okay, well, before I get into the meta study, the key assumption, what is the key assumption in Bootstrap? Yes?
Sample representative of the...
That the sample that we are resampling is representative of the population. Because what we are doing in Bootstrap is we are duplicating the sample that we have many times, and we're saying, this is my population. It's not. It would be as if we took this classroom and cloned it 100 times or 1,000 times and said, this is what UCLA looks like. And UCLA doesn't look like this classroom duplicated, right? Because then we would have too many statistics majors to start off with. And other things would differ from the UCLA population as a whole. But this is not a random sample either, so that assumption is a terrible assumption to make, right? But if we took, just some, I don't know, whatever. Okay, anyway, yes, question.
Is that non-parametric?
Yeah, not for non-parametric Bootstrap, yes.
Like when you do, like everything you said about not believing the table, that's...
Yes, for non-parametric Bootstrap, yes. Okay. All right. Yeah, sorry, this is all non-parametric Bootstrap. And generally, when people talk about Bootstrap, they're talking about regular non-parametric Bootstrap. Okay, that's the default topic of Bootstrap. Okay, so that's Bootstrap, but again, that depends on your sample being representative of the population. And so the meta study is an investigation into how reliable is Bootstrap, because we're not quite sure how reliable our random samples are. So according to Bootstrap, we run through this and we get a p-value. And so in the meta study, what we want to know is, if I had a different random sample, what kind of p-value would I get, right? So if my random sample was a little bit different, would I get a different p-value? And the answer is going to be yeah, okay? Because Bootstrap very much depends on the random sample you have. And in task 4, I didn't specify the qualities of the random sample you were supposed to take. And so I'll post up, I don't know, some kind of solution or some kind of video or something explaining. Basically, if we had taken small samples, then the p-values you get from Bootstrap are very, very sensitive to the random sample you got. If you have a small sample, there's a lot more variance that can happen in your small sample. And so your t-values or your p-values could vary all over the place, okay? But if you start taking really big samples, okay, then you have less variance in the sample overall, in the different samples, and your bootstrap statistics become more reliable, right? And that's something you guys should intuitively make sense, and is probably something like if you did power studies, you guys do power studies in 101B? I think I always keep asking this question, assuming you guys took 101B, but half of you say I haven't taken 101B yet. But anyway, okay. So that's something that we come across. So that's one iteration, and then the meta study. The meta study part is the for loop, okay? For I in 1 through whatever. This is, we get a new sample from the population. Okay, and then we do boot somewhere in here, and and then we calculate our p-value somewhere, and we can see, how sensitive are the results of our bootstrap test to the random sample we've selected in the meta random sample we have selected. Okay, does that answer your question, or do you have more questions about this? You got it? Maybe. Yes, in the back. What does boot output? Oh man. For that, let's look at help boot. It outputs a lot, okay? And really, we look at, do I want to, to load library boot, and we'll ask help on boot. Zoom in on this. How do I? Okay. So what boot outputs is it outputs a list of class boot, an object of class boot with these following components. T0, which is the statistic applied to the data. So this is going to be your test statistic of the data. And T is a matrix, each of which contain the replicate of the results statistic. So T is when you resample your original data with replacement, and then you apply the statistic function. What does it do? Okay. It also returns how many replicates it ran, the data that was passed to boot. Okay. The seed is the random seed which boot used to start, okay? And so this allows you to get, if you want somebody else to get the same results for Bootstrap, you tell them what seed you used, or you throw that in there, okay? Statistic is the function that you passed. So this is a lot of just kind of like status information. This R, data, the seed, and the statistic is basically just information about what was given to the function boot so that you can reproduce these results later, right? There's other things, simulation and statistic type, which I'm trying to recall. The call is exactly the string that you typed in to R to get boot to run. The strata, if you can have stratified Bootstrap resampling, which I guess could have been used for task 4, where you want to make sure that half of your sample is coming from one group and half of the sample is coming from another group. It could be used, you know, depending on things. It may or may not make a difference. Okay, and it basically just includes a lot of other stuff. One thing about what boot, so pretty much what we have been using is just this matrix T, and we've been applying things like the standard deviation to get the standard error. Because basically T is going to be an approximation of your sampling distribution, because it's saying if I got a different random sample, what is the test statistic that I would get? And you do this many, many, many times, and you can get an idea of the distribution of the different test statistics T that could result. But boot, with an object of class boot, there are other functions that we can apply, such as there are boot.confidence interval, boot.array, jack.afterboot, and things like that. These are methods that were not covered in our class, but you can read up on them. You can look up Bootstrap confidence intervals, which is basically trying to make a confidence interval based on your Bootstrap estimates. There's something called jackknife, which is equivalent to leave one out cross-validation, which may or may not mean anything to you at this moment in time, but it can be performed afterwards as a way to validate your Bootstrap estimates to see basically how sensitive these Bootstrap results are, you know, or how robust they are. So the output of boot is just this big list that gets assigned class boot, and the library boot contains functions and methods that can be applied to boot. Okay. Question? No question.
Yes. This question is about randomization. Sorry.
Okay. Okay. So you do have questions about randomization tests. That's fine. But I guess I want to make sure we're okay with the results of boot. Yes.
I have one question about boot. As to the function that right?
Yes.
What is the significance of index?
So the function. So what boot does. Okay. So your statistic function is always going to be a function of data, comma, index, okay? Because what boot does is when you call boot and you have your data and you have the statistic and you have R, what it will do is it takes these in and it says, first of all, it looks at the length of the data. Okay, and it's going to pull that out in n, and it's going to say, okay, let's say data has 100 rows, okay? So then n is equal to 100. And then what it basically does is it produces something called index, and this is going to be the result of sample 1 through 100. We want 100 values, and we're going to do replace equals true, okay? And so we are going to get something like 84, 32, 5, 16, 32, 27, etc., etc., etc. Okay? We are going to get 100 values that have been sampled from the vector 1 through 100 with replacement. Okay? Which means some values will be sampled more than once, others values will not be sampled at all. Okay? Then boot will take this and pass that to the function index. And this function will then need to subset the data using the indices. Okay, so you might do bracket like this or bracket comma, depending on the dimensionality of your data, it needs to subset the data accordingly. Yes?
I have a question for like that function. Why do you subset the index first and then split the data into two?
What do you mean split the data into
Like in
two?
homework, where we had like two populations, right? And the data was like a combination of x's and y's, and then you went to the index first and then split it to like x and y.
Oh, okay. So that depends on the statistic that you're calculating, okay? So in that case, the reason why it appears that we're splitting our data is because the statistic that we're calculating is the difference between proportions or means of two groups. Okay, I think in the homework we're looking at the proportion of group 1 versus the proportion of group 2. Under the null hypothesis, group 1 and group 2 are being drawn from the same population, or at least their populations have the same properties. So they're equivalent to drawing from the same population. That's why we are first going to, this thing is basically pulling all of our data together, throwing them into the same population, and we draw everything from the same population, and then we just arbitrarily call one group A, which is going to be a subset of D, like 1 through 50, and then group B will be a subset of D from rows 51 through 100, or something like that. Okay? What this signifies is that under the null hypothesis, everybody's coming from the same population. Therefore, there should be no relationship between what gets assigned to group A and what gets assigned to group B other than pure randomness. And that's what this is doing. It's saying who gets assigned to group A is just a result of who's in the first 50 and who's in the second 50, which is determined entirely by pure randomness. Nothing else, okay? And that is true under the null hypothesis. And this statistic is basically simulating new instances of the data while the null hypothesis is true, okay? If the null hypothesis is not true, then this is not an accurate way to calculate the statistic. And that's why we want to see how often do random samples produced while the null hypothesis is true end up still more extreme than what we got from our observed sample. Okay, so this Bootstrap is basically producing the random aspect that is stated to be true in the null hypothesis. Okay, so you have to think back to your Stats 10 course and your understanding of p-value, which is what is the probability of getting the data I've observed if the null hypothesis is assumed to be true. Does that make sense for you guys? Okay. So, but that's, this is an instance where this test statistic you're calculating is based on two groups, okay? You could have a test statistic that's based only on one sample, and then you wouldn't split it up like this. Yeah, question?
And for the randomization test, like, is the only difference that the sample will be selected without replacement?
On a practical level, yes, okay? The implications of that simple change from replace equals true and replace equals false, the implications of that are much greater. But on a practical coding level, then yes, that's kind of the only difference. Okay. All right. Let me. I want to